Welcome back. This is part two of chapter four. Remember, this is part two of three videos. So let's go ahead and dive in. We're at portion page 32, I think it was. 4-6. There we go. All right. So we're going to start in, and we're going to talk about the if statement. Now, we've talked about the if-else statement, which is either do this, else this. So if we had if expression is true, then do this. If it's not true, then you're going to do the else statement. Well, this is going to allow us to add a little bit more flexibility. It allows us to test a series of conditions until one is found to be true. Often simpler than using nested if-else statements. So this goes back to what I was saying is a lot of times organizations really frown on those nested if statements. They can get a little sticky and hard to read. And with if statements, you can oftentimes get away from doing that. So, and then this can be used similar to our typical thought process. If it is raining, take an umbrella. Else, if it is windy, take a hat. Else, take sunglasses. So here's that format. And again, this is kind of showing you an else if statement with single statements. So that's why there's no curly brackets here. Or you can use blocks, in which case you'd have curly brackets and several lines of code between the expressions. So in this one, we're saying if the expression, if that's true, we're going to do statement one. And this is where it's different. Instead of just having an else, we're saying else space if expression. And so we're saying do this one if this statement exists. And then thirdly, there's another one down there that says else if this expression. All right. So, in this if statement, you can see that we're doing hey, if the person's test score is greater than or equal to a score, then see how it's in all caps, so we know that it's a constant value, probably 90, is what we're going to say, especially since they have the greater than or equals to, then your grade is an A. Else if, and same thing, they keep doing this. Now, one thing to know is that one of these statements will occur, and that's it. We cannot fall into more than one of these statements. So, in this case, let's say that the test score is a 90. Well, if test score is a 90, then we'll put 90 here. This, and we'll say 90 is A score as well, where B score, let's say, stands for 80. C score is 70, 60, so forth and so on. So 90 is greater than or equal to 90, so we're going to get that grade as an A. But if you look, 90 is also greater than or equal to 80. So why is this B piece not going to go and actually happen? And the reason being, like I said, is once it runs one of these blocks, it will not run any other block. It will skip out of these blocks of code. So the fact that it went into the first if, when it's done, it will ignore all the other pieces of code and go on to the next standard line of code for it to run. Oftentimes, when we're doing development, we will oftentimes add this basic else statement down here. And you can see, and this is kind of what I know, I call it as a catch-all, right? And that's because if for some reason something weird goes on up here, we have this else statement just to cover everything. And it will fall into this invalid test scores. Now, what I will tell you is, interestingly enough, if you get into an organization that runs actual code usage tests, you may find that sometimes your else statements like this can never actually be ran, and your test might come up saying, hey, this line of code is unreachable. That happens. But what I will tell you is it's often a good exercise to go ahead and put these else statements just to catch the what ifs that aren't being that we've forgotten. And in this case, what if the score was something weird? What if it I don't know, anything? I can't even think of an example, but it was something weird and one of these else ifs didn't catch it. Then we always know we have something in the background that will catch it. Flags. So variables that signal a condition, usually implemented as a Boolean variable, are known as flags. Now they can be integers, and oftentimes when they are integers, we do consider 0 to be false and everything else is true. And as with other variables and functions, they must be initialized before you can use it. Now, it doesn't go much more into flags, which I thought was kind of funny about this. So let me give you kind of an example of a flag. Let's say, and we haven't really talked about them, but they're going to come up here soon. Let's say you have this code loop going on. And this code loop does some code, and then it goes back up to the top and does it all again, right? But one thing I could do is I could set up a flag up here that says we want the flag is going to indicate that the user has requested that the process be interrupted. So we're going to, let's go ahead and actually erase that, and we're going to call it an INT flag for interrupt flag. We're going to say at first that it's false, right? And now when we go into this loop, we're going to keep checking to see if this int flag that we have here is false. And as long as it's false, we're going to keep doing this thing until at some point maybe the user, through some kind of mechanism, says, hey, stop doing this, in which case in this code we're going to say, oh, set the int false flag to true. So now when it gets to the top again, it's going to evaluate that and say, oh, okay, this user wants to be done, and breaks out of that loop. So there's a good example of what a flag variable is. Other examples are oftentimes during registration process, we may set up flags that indicate whether the user has done certain steps, because some steps might be optional, but we eventually want them to fill it out. So we may set a flag like, hey, this person has never filled out their phone number information. And so while right now it's not mandatory, we still need to set that flag as false because it hasn't happened. It might, down the road, we might want to take a look at that flag and go, hey, it's been 6 months plus you haven't done your phone number. We really need you to do your phone number, kind of thing. So another good example of what a flag is. Then we got logical operators. Logical operators are used to create relational expressions from other relational expressions. And we did do an example a little earlier of this, but this is more the formal introduction to it. And the top is that ampersand sign. Two of them means and. Pipe sign. And this is different on each keyboard, so you're going to have to find this on your keyboard. But that is two, and it's known as pipe symbols. For me, it's the character that's above the slash key. And then this, which is an exclamation point. Oftentimes in programming, we call it a bang. Stands for not, and that reverses the value of an expression. So a true expression becomes false, and the false becomes true. So let's look at this chart here, and in this chart, we've got these variables set up right here at the top. So if x is 12 and y is 5, then this, because it's in parentheses, is going to evaluate as a true or false. And in this case, it is true. Well, 5 greater than -4? Well, yes, true. So when you have two trues, that will always equal true. I'm going to let you take a look at the rest of this grid and do kind of what I just did. And if you have any troubles, let me know. Shoot me an email, and we'll definitely go over it. So the logical AND operator in program. And this is funny because we talked about this. In fact, when we went over this in the last video, I already showed this to you as a possible way to shorten your nested if. And in this case, they actually did do that for us. So this is that and piece that I showed you earlier. Now that they're also doing it as well. The logical OR operator. So it determines the income's user. So this is saying, hey, is the income greater than or equal to the minimum income, or is the years less than min years? And then it's saying, so in this statement, we're going, hey, does a person make enough money and has been in their house enough years? Then you qualify. Else you're not going to qualify. This is the logical bang operator, and this is the not operator. So this will do just the opposite of what you just saw. So this is saying, hey, if you make over the minimum income and you've been in the house for more than the minimum years, then you qualify. Well, in this case, this is saying no. We want to actually do just the opposite. If the person makes too much money or has been in the house too long, then we're going to actually not qualify them. So think about the ramifications here. This one is kind of saying you need to make enough money and been somewhere long enough. This is kind of maybe you're applying for a loan. This one kind of says, no, you actually need to make less than the minimum income and maybe not been in your house long enough. And so by doing that, if you have too much income or too many years, then you've got too much income in years in your house to qualify. This is kind of more of a for those that maybe have low income, need assistance kind of programming. The bang has highest precedence, followed by the and then the pipe. The value of an expression can be determined by evaluating just the sub-expression on the left side of a logical operator. Then the sub-expression on the right will not even be evaluated. This is known as short-circuit evaluation. I'm going to take a moment here because this is actually really important to understand. In fact, we're going to kind of use the next little bit of slide to draw on here. So what this is saying is if let's say we have two pieces that are followed by another piece. If the left side can determine the entire expression, then the right side won't ever be evaluated. So remember, in an OR statement, only one of these need to be true. Only one. If both are true, great. If both are false, then it's not okay. So if in evaluating this number one side, and this is true, it doesn't matter what's over here. Because whether this is true or false, this expression is true. We only need one true in this. Now, if for some reason it's evaluating and number one is false, then it has to do number two. And if it's also false, then it's going to kick it back. But if it's true, then it would go ahead and say this expression translates to true. So short circuiting is when the left side does what it needs to already tell the compiler that it doesn't need to evaluate the next piece because no matter what, this expression is going to be true or false. Right, so that's why it's called short circuiting, because we are making it to where we don't even have to evaluate the second piece. Got a little excited there and flipped through too much. We are at 4.9. So, checking numeric ranges with logical operators. This is pretty straightforward. What we want to know is, hey, is the grade between 0 and 100? This is exactly how we would do that. You cannot do it this way. So this is right out. Doesn't work. Instead, this is where up here is how we would evaluate that. So is the grade greater than or equal to 0? And the grade is less than or equal to 1. So this is saying, hey, is it between 0 and 100? If so, then it's a valid grade. If you want to see if it falls out, then you're saying if the grade is less than or equal to 0, or the grade is 100, greater than 100 or equal to 100, then say invalid grade. So this guy is kind of doing, if we were looking at a number line, it's evaluating, does grade sit within this value line? The second, if you were to show it on a number line, is just the opposite. Is the value below or above a certain set of numbers? And 4.10, our last section for this video. Menus are menu-driven programs execute controlled by user selecting from a list of actions. A menu is a list of choices on the screen. And most often, especially in smaller console apps, menus can be implemented using the if-else-if statement. So, what we're going to do is we're going to display the list of number or letter choices for actions and prompt the user to make that selection. From that, using if-else-if statements, we're going to test the user selection, and if there's a match, execute in that code. If not, then allow it to go on to the next expression. So again, using the next slide kind of as help here, what we're simply saying is, a little excited, is we're going to ask the user, hey, look at this menu. We're going to see out a menu. Let's say there's 3 options. One is to add, second is to subtract, and then third is to exit. So we would then say if input equals 1, do add stuff. If input equals 2, then do subtract stuff. Else, because we don't have any other, we said 1 is add, 2 is subtract, 3 is to exit. So we don't need to do an if else. And actually I did kind of mess that up, didn't I? So this should actually be if else. There you go. Now that is how you create a menu-driven system using the if-else, if-else-if statements, and then finally also throwing that else statement in there. So that is the end of this video. Next, we're going to be talking about 4.11 and how we can validate user input. See ya.